In the diagram, the line AF is tangent to the circle AB, CD, E at the point A. BDE is equal to 117 degrees and EAF is equal to 46 degrees. And here we have this diagram. Calculate the value of angle ABE. And so here we have angle ABE. Let me highlight it for you. So let's highlight angle ABE. So we go to angle, this is A. So go all the way here, B and E. All right, so we want to figure what is the size of angle ABE. So we actually want to figure what is the one in the middle, B. And so this is the angle that we're trying to figure out what is the size of it, right? So let me use a pen to highlight it. We want to figure out what is the size of this angle right there, angle ABE. Now, in order to figure out what is the size of angle ABE, we're going to use the alternate segment theorem. And the alternate segment theorem says that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. Now, what does that mean? Notice that we have this angle here, theta, and it is between the chord and the tangent. And they're telling us that this angle, theta, is going to be equal to this angle that is subtended by the same chord in green. And we know that this angle is subtended by this chord because the legs of this angle rest on this green chord, okay? And the same thing can be applied here, right? So we have the chord and we have the tangent line. Okay, so I have that, we have the tangent line. So what is the tangent line? Well, the tangent line is right here. This is the tangent line. So you have the tangent line and we have the chord, okay? Let me erase all link. So we have the chord, which is in blue, and we have the tangent line, right? So we have this angle that is between the chord and the tangent. And we know that the angle between the tangent line and the chord is going to be equal to the angle in the alternate segment that is subtended by the same chord. And we know that this angle is subtended by this chord in blue because the legs of this angle rests on this blue chord. And so that means that if this is 46 degrees, this angle must also be 46 degrees because these two angles are equal according to the alternate segment theorem. Next, we have to calculate the value of BCE. Calculate the value of BCE. So we have C right there, and we have to figure out the value of B. This is B, this is C, and this is E. All right. So we have to figure out what is the size of this angle right there. All right, so this is BCE, and we need to figure out what is the size of this particular angle right there, this one right there, right? What is the size of angle C? Now, in order to do this, what we need to do is we can use the bow tie rule. And let me show you the bow tie. So you have this, and then go over here, and go over here, right? And then go over here, okay? Okay, so the bow tie rule, so as you can see, it looks like a bow tie. The bow tie rule says that if this angle right here is 117 degrees, this angle here must also be 117 degrees, okay? That's the bow tie rule. That these two angles, right? These two angles that are in the same segment are equal, all right? And so the angles in the same segment rule, or the bow tie rule, says that angles in the same segment are equal. So if this is theta, this must also be theta. And so that's why if this is 117, this must also be 117. And so the answer here is 117 degrees. Okay, let's move on to the next question. It says, calculate the value of angle BAE. Angle BAE. So angle BAE, let's go to angle BAE. AE. So this is BA, right? E. Angle BAE. So what they want us to figure out is the size of this particular angle. Like, what is this? What is this angle equal to? But if you notice that this is actually a cyclic quadrilateral. Let me show you the cyclic quadrilateral. Notice, let me erase all link. Notice what I have highlighted. This is a cyclic quadrilateral. Now, it's a quadrilateral because it has 4 sides, and it's a cyclic quadrilateral because all of the vertices of the quadrilateral lies on the circumference of the circle. So we have this point is on the circumference, this point is on the circumference, this point is on the circumference, and this point is on the circumference. So it's a cyclic quadrilateral. And what the cyclic quadrilateral says that the opposite angles will, well, the theorem for cyclic quadrilateral tells us that opposite angles in a cyclic quadrilateral must add up to 180 degrees. And so if we want to figure out what this angle is, we just have to take away 180 and 117, and then we'll get this particular angle right there. And so that's what this theorem says. The cyclic quadrilateral theorem, it says that the opposite angles in a cyclic quadrilateral total 180 degrees. So if you know that this angle is x, the opposite angle would be 180 minus x, because when you add them two together, you should get 180 degrees. And so since we already know that this is 117, in order to get this angle, we have to subtract. We're going to take 180 minus 117. And so let's do that. 180 minus 117, and that gives us 63. So that means that this angle right here, let's use it right now. This angle is, let me use a pen. So it means that this angle right here is 63 degrees. How do we get that? We subtract 180 and 117, and we get 63 degrees. And so if we add 117 and 63, that gives us 180. And so the answer here is 63. And that's the answer to this particular question. Thanks for watching, and I'll see you in the next video.